Hello everyone, thank you for joining us for our session today. So today we're going to be giving a Maple training session for Maple 2019. This is going to kind of feature a lot of features that you'll notice from different versions of Maple, so it's not exclusive just for the latest version, but it's going to be kind of a cumulative edition of the highlights of what it is to use Maple as an educator. So I'm going to be walking through a number of different areas today. Let me just go over here and expand my workbook palette here. I'll be talking about an introduction to begin with. I'll show you some tricks in the interface. We'll proceed to looking through some visualizations. We'll use our interactive plot builder, items like that. I'll briefly cover authoring interactive content as well in Maple. And finally, we'll leave you with a couple of resources. But to begin with, what I'm going to talk about is the Maple interface. And that's what you see on your screens in front of you right now. I have a Maple document open. This Maple document has lots of sections which we can collapse and expand. This is text we're seeing here, but you can mix and match text and math all over the place here. I'll start actually at a slightly different place than usual. Where I'm going to start today is on our start page. And this looks a little bit different in Maple 2019 in that it's a little bit shorter than what you may have seen in previous versions, if you have seen the previous version. But the start page is the first thing you will see when you open up Maple. And if you want to just start up Maple right away, you want to open up a new document, a new worksheet, you want to just start typing in some math, you can click either one of these, and what that will do is it will open up a blank document for you. This blank document is your canvas. Here you can start typing in things like x plus 1 equals 0, that type of thing. If you go back to your start page again, you can open up a worksheet. And the key difference between the document and the worksheet is really just going to be that the worksheet is going to have these prompts here. So the prompts will just delimit where your input is. If you press F5 on your keyboard, you can also use this in kind of a classic way. You can kind of see and do an integral here, integral of sine of x with respect to x. Hit return, get a result. So it's up to you which way you want to work inside of Maple. You can work in worksheets with either two-dimensional math or one-dimensional code, or you can work in documents, and the documents are a little bit more for dressing up your code, making the code look nicer, inserting text as well as math as well as images. And I'll talk a little bit more about that in a bit, but either one of those would be a good place to go to begin with. If you're a little bit more seasoned, other things you'll see on the start page includes, say, what's new. You can press this to learn what's the latest features we've added in the latest version of Maple. Documentation will bring you into our help system. Maple Cloud will open up the online Maple Cloud website. Here you can go to share your documents. Math apps will show you a collection of interactive documents. List of packages will give you an idea of all the different areas that Maple can be used to solve problems. And the plotting guide will show you our collection of different visualization types. So there's 2 or 3 different types of plots in Maple. This will show you a full list of those. If you're entirely new to Maple, you can also go down here to this section, New to Maple, open this up. You can start by watching a video to learn a little bit more about Maple, but then you can proceed to go through resources that will get you started. So here we have a quick start guide. We have the Maple portal. We have an engineering portal. These are good places to go to begin with. If you're looking to kind of have a full regimented start within Maple, I always recommend the user manual as one of the first places to go. And then as you're getting a little bit more advanced in your use of Maple, the programming guide is an excellent place to continue. Other things you'll see on this list include direct links to our user community forum. So Maple provides our user forum. You can go there and ask a question, get an answer. All right, so that's a very quick tour of that start page. That's the first thing you see in Maple. Of course, if you are seasoned, you don't want to see the start page anymore, you can also just uncheck it, or check this box here, don't show this at startup. It'll disable that page for further instances of Maple. One other thing I wanted to show you in the interface is the Maple Cloud. If you go up here to the top of your window, you'll see here there's this sign in button. Here you can access our features that we have available online. So there are things like our math apps, our public documents. If you wanted to see what packages you have that can add to your Maple experience, you can go to the package cloud, and this will show you all the latest versions of user customized packages. You can also sign in, and if you sign in, you can access your private files, you can administer your own private groups, and you can kind of interact with users in a very different way. All right, so that kind of covers those elements. Other things you'll see me working with today, you'll see me kind of using the toolbars that you see here, and I'll be jumping back and forth and using these palettes quite a bit. So let me flow into the next section here, and I'll talk about these palettes in a second. But as I said before, if you were to open up Maple, and start with a new document, then you'd be given kind of this just blank cursor blinking in kind of a bluish box. And what you do with that is you just start typing in that. You type in 7 minus 2, hit return, get a result. That's the whole idea with Maple's input and document mode. For exponents, we would do 3, and then we would push Shift 6 to get a caret symbol, at least on US keyboards. To get 3 squared, I press the right key to return to the main diagonal. So you see here how I'm moving back and forth. So 3 squared minus 9, hit return, have a result. We can create fractions using the /. So if we do 3 / 7, again we'll press right to move to the main to the main axis kind of our expression here. So 4 / 5, hit return. And I'll do an example here, and this is actually to show you that Maple can compute and store integers of arbitrary size. So let's do 333 factorial / 2, and then I'll press that caret symbol, the circumflex. So 2 to the power of 31. I'll right cursor over to here, and 141, and then Shift 6 to move up to the power of 41, and I'll hit return and get a result. And Maple can also evaluate with arbitrary precision. And say we had something like pi, and I'll type this in this way first. So if I type in pi, capital P, I can then press escape on my keyboard. This will give me a command completion list. And I can see here that we could do pi, as in the uppercase Greek letter pi, or we could do the constant pi. So let me just grab the constant pi, and if I hit return, this will just get you back pi. So you know, this is an exact solution here. We're not actually doing anything here. We're just getting back that value of pi. But if I go back up here, I hover over the context panel. So again, I put my cursor on the output here, go up to context panel. I can choose approximate to 100 digits and get a result back. So very quickly what we did there is we can use arbitrary precision in Maple to show calculations or to show constant value or different values to an arbitrary number of digits. So we'll come back to the context panel in a second, but let me show you a couple more examples of using Maple's palettes. And for this I'm going to open up our expression palette over here on the left side, and let's build out this sum. So I'm going to scroll down right near the bottom, choose the sum, and then you can see that there's a little blue box here. So I'm going to start typing, and that kind of gets rid of the blue box. I've now replaced I with K, and I'm going to press Tab on my keyboard. I'm going to move over. Now we're blue box on the K, press 0, tab up to that, n minus 1. And then the term I want to do the sum for is actually, I'll go back to the expression palette, grab E, and I'll change F here to K, and I'll press return, have Maple return a result for us. All right, let's do another one from the, let's actually grab one from the calculus palette. This is available. We have a lot of similar functionality that is available in different palettes, but the calculus palette unlocks a lot of functionality that's kind of a little bit more calculus specific. So let's grab the partial derivative of x, and again I'm just pressing the tab key to move through, and then x, and then the Shift 6, squared, right key over, minus y, squared, and press return. So there's our result from that one. Now let's talk a little bit more about clickable math. You saw an example of that when I during the first section when I talked about pi being inputted, but let's do another example. Let's use this expression template here for an integral, and let's do x squared minus 1 and then dx. So first thing we're going to do is we've input this. Let's just evaluate that, and that gives us 1/3 x cubed minus x as a result. So at this time I'm actually going to go over, I'm going to expand our context panel. So we saw before we can hover over this to get results, but if I click here, this will pin it open for us. I'm going to use it for a couple different things now. So let's go over here, and we can choose a number of different things from this menu, but let's just choose quickly here and choose 2D plot. And this gives us a 2D plot of 1/3 x cubed minus x. Now if I click on this plot, you'll also notice that the context panel itself will change, so it is context sensitive. Whatever you click on, be it output or plots, the context will change and you'll be able to apply different operations to the item that you've clicked on. So let's do another one here. So 2x plus 5, I've already typed this into Maple, is equal to 3 over 2x plus 1. And you'll see that the context panel has already switched over for us. So what I want to do now is I want to go over to solve this, and let's solve this for variable x. And this no goes through, it sends a command away, and we get back that x here is going to be equal to minus 8. So what I'm doing when I'm clicking on an expression or clicking on a plot is I'm using something in Maple we refer to as clickable math. So the whole idea here is that you have some expression that looks like mathematics, and you click on it, you apply integration, differentiation, plotting, what have you through this menu system, and we're kind of clicking through the actions or the operations we want to perform. So let me show you a couple more examples. Let's do one here for a differential equation system. So here we have the system as defined here. Let's find a solution. So let's go over here and we're going to solve dE for y of x. This will give us back a solution. Now we could of course refine this a little bit further if we had some initial conditions, but for now we'll just solve it this way. And here's another one we're actually going to use. We've kind of inserted a template, we've built out a calculation of integral, and we're going to use some assumptions on this as well. So we've already typed all this in, but now we're going to add this keyword here, assuming k is greater than 0 and less than 1. And this is kind of using our language in some ways. I'm going to show you more examples of that in a second, but here we're able to input this, looks like math, but we're also able to then put on some assumptions on our system. Let's look at symbolic minimization. So we've got sine of x, and to minimize this, we can do this in a couple different ways. If we could go over, we could click on the menu system, or we can use the minimize command. So let's do a minimization of sine of x for this range here. So we want to look at the minimum value in the interval here of 0 to 4. So that gives us back sine of 4. That's an exact result. As we saw before, we can go to approximate, and that's going to be the minimum value is going to occur at minus 0.75. I'll do one more example here for minimize. So let's bring in the first time we're going to see assignment. So assignment in Maple is happening through this colon equals operator. So if I wanted to assign an expression to a value, we'll do expression expr, colon equals, and then we're going to do minimize of our expression, and then we're going to do some ranges for x and y. We'll hit return on that, and we'll get back this expression is equal to this value now. And what this allows us to do then is use commands on the results. So here we can do eval f to 200, so that's the evaluate using floating point arithmetic command. And we're going to do that to the expression for 200 decimal places. And at this point I'll also mention briefly that now that we've assigned something to expr, you can also see that live over here in the variables palette. So if we drag this out a little bit, you'll see that expr is now assigned to a value, and its value is as follows. All right, solving equations and inequalities. Here are a couple more solve examples for you. So we have here x squared is equal to 2 to the power of x. Let's again return to our context menu, solve this for variable x. This gives us back some solutions for x. And under the hood of what's happening here when we click on it is we're using a command in the Maple language. And in fact, what we're using in this case is we're using the solve command. So here's another way of solving an expression, or an inequality in this case. So we can do solve this expression here for x, hit return on that, and get back our solution space. Now it's a good time to kind of transition into, that last example was an example of the Maple language, so let me tell you a little bit more about the Maple language itself. Maple's top-level language, it features a number of commands. There's integration, there's differentiation, there's plotting. It's kind of the most frequently used commands that you'll use in your day-to-day work. But Maple also has a large collection of different packages. So we can see here, this is a collection of packages that have been designed for students. So these are packages that kind of map into a Calculus 1 class, or a linear algebra class, or a first-year statistics course. So these are packages that have a collection of commands that you only can access those commands once you load the package. You can load a package in Maple using the with command, or you can just go up here to the tools menu and go tools, load package, and this is going to allow you to load some of the most commonly used packages in Maple, and you would just choose one from here, and it would load that up so you have access to those commands. So what happens, if I just do a quick example here, if we do load of with student basics, is it loads the commands which are inside of that package, and this one only has 3 commands: expand steps, linear solve steps, and practice sheet. But it loads those into Maple's top level namespace. So then you can just call a command there, such as linear solve steps, which returns all the steps of solving a linear problem to your screen. So here we can just access this right away because we've now loaded student basics. So I won't get too much further into package loading and so on in this webinar today, but there's certainly videos on our YouTube channel that will cover this in depth if you're curious about learning a little bit more about that. But the key point here is A, that Maple has a number of packages that you can use. You also see that from the start page. If you go back to the start page and click on list of packages and go into the Maple Help System, you'll be able to view all the different packages. So A, we've got a lot of different commands contained within these 150 or so different packages of Maple. But B, also that we have a number of packages which have been built for the classroom. And this is kind of one of those cases where I would certainly encourage some homework for you as a listener to go out and have a look at some of these packages, see what's available, and see how this would fit into any one of the classrooms that you're teaching today. And each one of these packages, they actually include interactive documents. They also include what we call interactive tutors. So let me quickly show you one from our Student Calculus 1 package. I'll go up here to Tools, Tutors. You'll see the same breakdown for student packages as I just showed you. But I'll go to Single Variable Calculus, and I'll choose Differentiation Methods. This is going to bring up our Differentiation Methods tutor. And this is a little bit different than what you might see with some of those step-by-step solvers. What you can do here is you can enter in an expression, press Start, and then as a student, you can step through the differentiation or the integration or the limit. You can notice the multiplication of the expression as a hint. You can apply the product rule. You can get another hint. What's a differentiation variable? If we're not sure, we can apply the identity rule. And we can apply the sign rule, and the problem is complete. So what this allows us to do is it allows us, as a student or somebody interacting with it, you are now able to step through the calculation. You don't just see the step-by-step solutions. You're actually interacting with it. You're able to apply different rules. And when we close this off, you can see here that Maple's returning the step-by-step solutions, but it's also telling you what rules were applied along the way. So this is kind of vital as you're learning a calculus. As you're kind of going through and learning this for the first time, we're providing those tools that will really help you to kind of master your skills. I won't spend a lot more time on tutors today. As we said, there are tutors for lots of different subject areas here. I often show one here from linear algebra, say the Gauss-Jordan elimination. This one would just help you with checking the arithmetic of row reducing a matrix. But you can spend a lot of time going down any one of these pathways, and I would absolutely encourage any one of you who's teaching a subject that is listed here to try out some of these tutors or try out the packages and see what's available to you there. But to conclude my first section, let me tell you a little bit more actually about kind of linear algebra and working with vectors and matrices in Maple. And for this, I'm going to open up our matrix palette. And the first example I want to show you is, let's work with a 4x4 identity matrix. We're just going to do something simple. Let's just click up the numbers here, 4x4, and I'll choose type to be identity, and I'll just insert that matrix, and there's our identity matrix. So that's how we would very quickly build a matrix in Maple. You'll notice that this actually looks like a matrix. So there's a matrix command under the hood here, but it actually will display like a matrix. Let's do another one where we can actually build something with custom values. And I'll choose here 3 rows, 3 columns, type custom values. I'll insert that. And now the blue box here has returned. I can now step through it by pressing tab. 1, 2, 4. I'll continue just tabbing through, and we're just kind of going through row by row, entering in values. -1, 0, 3. And so now we've created this matrix, and of course, as we saw before, anything in Maple that you enter does have its own context. So we can go over to our context menu, and let's go to standard operations and quickly find the determinant of this matrix. Let's do another example here. Let's insert a 2x2 matrix, and custom values, we'll do 1, pressing tab, 4, 7, 3. And I'll go and I'll just do a star between these two. And then we'll do 2 rows, 1 column, and we'll insert 5, 6, and sorry, we should do a dot there instead of the star. So we'll do that matrix dotted with the column vector, and we get back a result. So that's very quickly how you can multiply those two together and get a result. Now for doing larger matrices, the command that you need to know here is actually called matrix. It's pretty evident. But what we can do is we can run matrix, and the first argument is number of rows, second argument is number of columns, and the third argument, if you use it, is a generating function. So in this case, I'm going to generate random numbers between 1 and 10. So if I run that, I get back a result, and what you see here is a little bit of a preview of what that matrix looks like. So here we see the first 10 rows and the first 10 columns, but obviously we can kind of see that this has been elided in some way. So we see dot, dot, dot. And in fact, we actually are showing here the dimensions. So there's 2,500 rows, 200 columns of this matrix. If you go and you double click on this, this will bring up our matrix browser. From here you can actually browse through and look at all the values inside of that matrix. You can look at an image histogram here just to prove to yourself this is in fact just noise. There's no periodicity or anything crazy going on. But this is a randomly generated matrix of values. So you can click on it and you can do that in that way. You could also expand Maple's defaults for the size of the display for matrices. There's an interface variable for that. Typically Maple will only show you the first 10 rows and 10 columns, but you can expand this to any number of values if you really wanted to. In fact, if you go over here, I believe there's an option here. Maybe it's not even available for larger matrices, but there's a value here for, if we go say a smaller one, let's do 20 by 20. There we are. Now we can show all values, and there's the whole 20 by 20 value matrix there. So again, if I click on a matrix that's larger than 10 by 10 and just choose show all, then you'll see this entire matrix shown to you there. So I guess the reason that we don't show it for 2,500 rows is simply that it would just take up so much screen real estate. But there are ways of unlocking that value that we can certainly talk about. Or if you have a question, please feel free to email our support team at any time. But let me move on and do a little bit more about visualization. This is kind of one of the key topics inside of Maple, and this is what we see people returning to use Maple again and again and again. So let me start by doing a couple examples of plotting in 2 dimensions. And let's start, I'm just going to grab this expression here, drag it down and drop it because it saves me typing. So let's plot the graph of first sine of x squared. And let me just grab that first. I'll just execute that, drag this one down, drop it as well. So let's grab here sine of x over 2 first, and I'll use our option right over here to quickly generate a 2D plot. And then let's go back over here again, and let's just grab here sine of x squared, drag it down, drop it right on top. And that's a way to very quickly put one plot on top of the other plot in an existing plot structure. So this is kind of a trick of working with Maple, is that you can quickly generate one plot, but then you can superimpose another plot on top of that just by dragging a math expression right on top of an existing plot region. So for plotting, I always like to talk about commands. So the command that you need to know for plotting is just called plot. And if we want to plot x squared over the range x 0 to 10, what we'll do is just type in plot x squared. X is 0 dot dot. This denotes a range in Maple. 0 to 10. Hit return, and we get back the plotted result. As I said before, you can interact with plots as well. I can go over here, change the color of this line to blue, and maybe we'll do some line thickness as well. Let's do line width. Let's crank it to 6. So you can interact with the plot through this menu system. Other things you can do is you can go over here, you can export, say to a PNG file, SVG file, directly from this menu as well. Let's talk about plotting in 3 dimensions. So let's plot another expression here. Let's do sine of x plus cos of y. And we'll do this in 3 dimensions using a context menu. We can do this a couple different ways. We can choose 3D plot here, or we can scroll down our list here to plots, 3D plot for x and y. So there's our quick 3D plot of this plot system here. For 3D plots, the command you need to know is just called plot 3D. Its arguments are as follows. So the first one we can do here is something like height, and then we can do angles from 0 to 2 pi, heights from -5 to 5, and we're going to do a cylindrical coordinate system. And there's our resulting plot there. And another way to interact with plots in Maple is actually to use what we call our interactive plot builder. So I've shown you kind of automatic ways of just getting right to a plot, but say you're not really sure of what plot you want to generate, or you want to kind of experiment with different viewpoints into an expression. Plot builder is certainly the tool for you. So let's start with x squared plus y squared, and from our context panel over here we'll choose plot builder. And this is going to change out our context system altogether. Everything's going to go blue all of a sudden. We're going to have different options available to us. And from here we can choose 3D plot, and we'll get the 3D plot of that system. But now we can change all the options that we have within 3D plotting commands. So here I'm just going to make this into a surface, change the shading scheme. We can even go back here, say that we chose not to do a 3D plot, instead we wanted to see how this looks as a 2D contour plot. So now we can see contour lines. These are values for x squared plus y squared for these different contour lines. Now we can change the thickness of the lines, we can mess with color schemes here. So it's a very interactive interface. Other things you can do is you can press this button here, show command, and this will insert the command that you can use inside of the Maple language to regenerate this plot. So if I go down here to another line, I can just type this in, hit return, and have that plot generated for me. So this is not only a way to generate and build plots, it's a way to learn the syntax and to experiment a little bit more with plotting in Maple. And I'm going to show you another example of plot builder in a second, but animations, in addition to visualizations, are kind of really important for why people use Maple today. And if I was to say use just a couple of simple commands here, I'm going to use matrix to create a quick matrix of x, y, z values. So we'll see kind of 3 columns here. And then we have a plot 3D of a sphere of radius 1. And then we're just going from 0 to 2 pi, y from 0 to pi, spherical coordinates. But the key point here is that we're specifying a viewpoint. So we're going to follow a path. Let me just turn off the axis here. And then what this does is it actually gives us a way of making an animation. So in this case, what we've done is we've declared an animation matrix. So we're starting at a point 600, 600, 600. We're looking at a surface which has this radius 1. And we're going to land at the surface of 1, 1, 1. So animations are pretty straightforward and easy to create in Maple. And you can create them very easily through the Maple command language. But I'm going to show you an example here of how we can do that using the Maple plot builder as well. So say you have an expression, and this is a parameterized expression. We've got cos of t sine of t of 2 plus sine of a times t. So we have some parameter value we want to look at, which is great because this allows us to kind of view it from different values of a. And then what we have here is we have parameterized expressions for the x, y, and z terms. So let's again choose plot builder as we did in the previous section. This will swap out what we have before. Let's now go up to animation, and we'll make a 3D space curve animation. And we can go through here, we can have a look at the different options. And we'll see here that the animation parameter is selected by default to be t, which is wrong. We want to actually make the animation parameter a, because t is how we've parameterized this system. And let's go from 0 to 20, we'll say. And leave t alone down here. Let's build this animation. And then let's just watch how a changes. So plot builder gives us a way of generating animations when we have an expression or some type of parameterized system where there is an actual parameter which is our animation parameter. So here we can parameterize the system, we can view different values of a, we can play it back. If I right click on this, we can export to the GIF file format. So if you wanted to see this as an animation somewhere else, you can of course do that. So before we leave visualization, I wanted to throw out a couple more examples to you. Let's do an example where we plot some data. So to do this, I'm going to import some data. I've actually got some attached to our workbook here. So this is just an iris data set. This is also available inside of Maple's data files. If we use the import command, we can import this file. This comes as a data frame, which is kind of like a matrix, but it's a little bit more rich than a matrix in that it has column headers, maybe row labels if they're available, and it's a little bit different that it can store heterogeneous information. So here we have floating point values alongside of strings. But now that we've imported this into Maple, we can now go over to our context menu system, choose visualization, and let's quickly do a box plot. And we'll do that for all of the numeric columns. So I'll just choose the first 4 here, press OK, and have that return an annotated plot for us. All right, so there's a lot more we could talk about there. I'm going to leave that one alone, but certainly you can experiment more. There's a lot of different data plots which are available within Maple. Let's talk about exploring mathematical functions. We have a command in Maple called the function advisor. And if you're looking to have a little bit more information about that, I've typed in function advisor now, so you can see the command. If I was to press F2 on my keyboard, that will actually do a search inside of Maple's help system and pull up information about the command that I'm typing in. So I'm just going to show you here very quickly. This is the function advisor. It provides information on mathematical functions in general. And if you run this command on various expressions or various functions, you'll see here that it'll kind of return a long list of information. So in this case, EI, exponential integral, here's a definition. We can go down here to a plot, and here we see the 2D plot, as well as here we have some three-dimensional plots. We can look at branch cuts, we can look at special values, we can look at differentiation rules. All this information is contained within the function advisor. Let's run the function advisor with some more options. So function advisor branch cuts of arc sine of this expression here, and we just want to generate the 3D plot. And here's what we get back. Let's do function advisor plot of Jacobi SN. Here we get back a whole bunch of 2D plots as well as some of these 3D plots. So this is really cool stuff. We store a lot of information in the function advisor, and this is just kind of a portal for diving a little bit deeper into mathematical functions. Now, what I've shown you today, this is kind of really just scratching the surface of plotting in Maple. If you go into our Maple help system, you'll find everything you need under the plotting guide title. So just do a search for plotting guide, or if you're again on your start page, just choose start and click on plotting guide. And here you'll see is a list of all of, say, the new plots we introduced in Maple 2019, or 2D line plots, 2D filled plots, 2D vector and grid plots. You'll see all the different plot variants we have inside of Maple, including all the ones featured in our student packages. They're all covered here on this page. So this is kind of a great place to go. If you're not really sure kind of what plot you're looking for, you can look at one of these images. You can say, okay, that's exactly what I'm looking for. I can go and make a plot using this command. All right, let's move on to another section. I want to talk about authoring interactive content in Maple. I'm showing you a lot of different stuff in this one. This is kind of a highlights reel for all the different stuff you can do inside of Maple. For the moment, I'm just going to collapse this context panel, and let's open this up. I've shown you a number of different examples. I've been talking about Maple documents and various things inside of Maple, but I haven't shown you anything yet that's been interactive in some way. Now, if we're kind of defining what I mean by interactive content, what I could say is that we have these components in a Maple worksheet, and if I use a slider, if I use the dial up here, what we can see is we can move a plot. We can see how a function and its derivative are changing for different values of these two parameters here. So phase shift, it moves and it changes this value as well as the one below. Amplitude, it moves, it changes, and we can see the plot of the two. So what I mean by interactive here is really that you're not really running any commands or anything like that. What you're doing is you're just interacting with some type of control. So we have two controls here, one for phase shift, one for amplitude. We have outputs for these inputs. So we have function, derivative, and the plots. So what we have inside of Maple is we have what we refer to as embedded components. If I go back over to our palette, so here, we'll see components. These are these components you can use to build interactivity into any of your Maple content. So you can add these dials, these gauges, and that will help you to build interactive stuff inside of Maple. Now what we tend to do with every release of Maple is we add more interactive content. And what we like to do inside of Maple is we like to match this content up with content in the classroom. So if I go here to Tools, Math Apps, this Math Apps guide collects together interactive documents in a similar fashion to the way that I mentioned tutors or student packages in Maple are kind of segmented. So for this, we'll see algebra and geometry, calculus, computer science, discrete math, engineering and finance. There's a whole bunch of different content here, but it's all kind of collected into these bins that you would see in the classroom. So let's do some different examples here. Let me scroll down. I'm going to grab the first example here from geometry, Archimedes' approximation of pi. And this opens up in Maple. It's an interactive document. And the way these are constructed is that we kind of first cover a concept. And we don't go into a lot of detail here. Like, this is the type of stuff that usually gets taught in the classroom. So we just kind of give an overview in case somebody needs a quick refresher. But what we really focus on is we focus on making something that's interactive that can help have the conversation about the concept. So here we have a slider, and this slider changes the number of sides that a polygon has. So if I do this slowly, we can see as we are increasing the number of polygons, we are getting closer and closer to the area of that circle. So this is a nice way we can kind of make this interactive in lots of different ways. But we kind of add this because this is the type of thing that you can then use in the classroom to show interactivity of some type of concept. Let me jump back to our Math Apps guide again and show you a couple more. I'm going to scroll down a little bit here, and I'm going to get down to calculus. I'm going to show you two from calculus. One, I'm going to show you Riemann sums. So the Riemann sums app, again, it walks you through the concept. And below there is some type of interactive app here. So here we can choose upper, lower, left, right, or midpoint. We can change domain, range, number of partitions, and so on. So it's interactive in a lot of different ways. And let me show you another one here from calculus. I'm going to do solids of revolution, volume by disks. And this one's neat because what I like about this one is actually you can just go in here, you can draw out a line, and you can see how that line is then being revolved around an axis. So that line I've just drawn out here is now being revolved around an axis. We see the volume of that solid as we've revolved it. So they're all very interactive. We can kind of go back, we can animate, we can see how this one is being revolved around an axis. And we can use them for interactive content for that classroom. Now we've created a lot of material inside of Maple. There's as many as almost 500 different applications featured in Maple. But we also try to make it easy for you as a user of Maple to create new interactive material. So let me show you how you can do that using the Explore command. And the Explore command is really just built to create interactive stuff. It's kind of really built to insert something that's interactive into your worksheet. So let's use the Exploration Assistant to examine the behavior as k is varied of the sum from 1 to n. So kind of the sum of the first n natural numbers. So I've got my cursor over here. Let me go over here again. I'm just going to quickly pop over here and use Explore on this expression. I want to keep n fixed, so I do want to explore values of k, which is our exponent here. I'll leave everything the way it is here. I'll just choose Explore. And what we get back is we get back one of these sliders. But now we can slide this out, and we can see different values here. And of course, you can go back, like anything in Maple, you can go back and change the expression any time. Let's again choose Explore on this expression instead. Skip n, Explore. This will return something that's a little bit more familiar. There we go. For different values of the exponent here of exponent k. Now Explore really starts to come to life when we start looking at other parameters. So say parameters of a 3D plot. So here we have a 3D plot, sine of a times y times b times x squared. I just happen to notice here that a is already defined here in my session, so let me just unassign a, and I'll come back here. And what we'll do again is we've got plot 3D, and we've got some ranges already defined for x and y. I'll go back up, choose Explore. We've got two parameters, a and b. Let's change a to be from -2, and I'll do star pi, and 2 star pi, so -2 pi to 2 pi, and we'll explore this. And this returns now interactive controls for a and b. We can see how if we change a and b, how this surface is changing. So Explore is really that way for you to get in close and understand kind of what the mathematics is telling you, to kind of see how a parameter will affect and change different things. So similar to the language examples I showed you before, Explore is a command in the Maple language. We can use it kind of in the following way. Here we have Explore being run on a Maple plotting command. In this case, plot tools polygon. This is a polygon, so it's just going to be defined by the points we give it. So in this case, we're going to define 3 points, or 3 basically sets of points. So x1, y1, x2, y2, x3, y3. So these are based on the corners of a triangle. And what we're doing here is we're just going to give some additional options to the Explore command. We're going to give it a title, some parameter settings, some initial values. And when we run this, what we actually get Explore to generate is an interactive plot. We can drag the corners of this triangle around. We can drag them over here from the slider components as well. we have Explorer able to generate a lot of rich and really interactive things. I'll show you one more example here. Let's use Explorer on a command from the escape time fractals package. So in this case, we're going to use it on Mandelbrot fractal. We've got a couple of parameters here. One is zoom, the other one is iteration limit. And let's just play back this animation. Again, this animation here has been created by Explorer. And let me uncheck A. We can just do a parameter sweep through for zoom values. But this is really cool now because we can change A on the fly. We can have Maple doing a parameter sweep while I'm changing A. So Explorer, it creates and kind of glues together all this interactive stuff in some way. And if I was to go back up here, let's grab, say, this one here with the plot. If you wanted to make what we call an interactive application, you could just grab what Explorer creates for you and just go to a new document and just paste it in. And here, if we just save this, if we submit this to the cloud, you have an interactive document that you can share with somebody. This will work on its own. So Explorer is that app builder. It's that command that you can use in order to generate something that's highly interactive. And that's kind of where I want to finish off this point, is that when you have something created that's interactive, you can then share it with your peers, with your students, or so and so on. So if you were to create an interactive application, even like this one here, if you were to sign into your cloud, just go save to cloud, that will put your application into the Maple cloud. Once it's in the Maple cloud, then your students can look at it. So if I say open up math apps here, if they've got a copy of Maple, they can just go and they can pick a math app out of this math apps group here. This will open up in Maple, and so if they have Maple. If they don't have Maple, on the other hand, then they can just open up Chrome. They can just open up Chrome and go to the Maple cloud and just see it there. Another thing they can do is they can download the free Maple player. So the free Maple player is on our website. It's a download. It's kind of like just a reader of Maple content. But if your content is interactive in any way, then they can open up that content and view it inside of Maple. All right, let me show you an example here of the Maple cloud running. So I've just gone to this website here, maple.cloud. If I go to the same group here, Math Apps, you can see I'm not signed in at this time or anything like that. I can go sort by date. I'll grab one of the more recent apps I was working on. And we'll grab, say, the sorting algorithms app. This will open up this math app. And if you wanted to share this with a student, you can always just grab a URL. You know, the URL is simple enough. You can just put that into an email. A student can grab that. And then students without a copy of Maple can just choose different sorting algorithm and watch as the sorting algorithm evolves. They can watch the animation as it flows through. So all the stuff, this is Maple content. It's being delivered to you live through the Maple cloud. So it's online, it's live, it's free. So it's a great way of interacting. It's a great way of sharing documents. And when you go here, sign in, save to cloud, that cloud is accessible through Maple. It's also accessible online through the browser. All right, I'm going to start wrapping up now at this point. But what I do want to mention at the end now is there are a number of resources available to you. I've covered a lot of material in this session today, and I haven't done it justice. You know, there's a lot of areas today that we could really go in depth and explain a lot more. I definitely recommend that everybody goes and checks out our YouTube channel. It's MapleSoft Video is our handle on there. Go there and you'll find videos that will go much further in depth on some of these subjects we've been talking about today. So if you did want to learn more, if you want to kind of expand your programming knowledge, whatever the case may be, you'll find a lot more in our MapleSoft Video YouTube channel. What's more, if you wanted to ask a question, if you're using Maple and you kind of have a question, does Maple do that, or can somebody help me with this code? Maple Primes is our main user forum. So go to www.mapleprimes.com and just ask a question. You'll find a great user community there. There's lots of questions and answers going on. Our developers are constantly posting on there. And it's just a great community to kind of engage with, to learn a little bit more about Maple, and to kind of just broaden that knowledge base. Of course, you also find us on any one of the other popular social networks. You can follow us there in order to kind of get updates on what we're working on and see kind of developments throughout the year as we move towards our next version of Maple.